Welcome everyone to this update. According to the YouTube comments here, of course I should have run this excessive LTO benchmarking with -03-FLTO because 03 for the most optimization. Certainly, so of course I've done that. Your wish is my command or something like that. And raise your hand or leave the comments. Pause the video, pause the live stream, leave the comments below. What do you think are the results? Certainly super amazing and impressive, right? So yeah, something like that. So we have here a new line, of course, even new line I've run with LTO 16 because that gave a tiny little speed up. Most of the results otherwise are the same anyway. So 03 LTO here. We can directly, so build time, as you have seen here, sometimes, well, build time was a little bit faster with parallel 16. So this is build time, just how long do you wait for the result. And so comparing here 02 if LTO 16, so build time, yeah, a second longer, so 25% longer here, also here 7 seconds, 10 seconds, so also 25. Here even nearly double the compile time for gzip. Also here nearly double the compile time, although we run this multi-threaded, 16 threads, sort of kind of whatever GCC is doing with that. So here 10 seconds lame to 16 seconds, so yeah, 60%, well, not really double but quite, and also here. And also LTO 16, so that is this line. So in set standard we get from 6 seconds to 7 seconds, not really 25. Somehow set standard, this is why we have a wild variety of benchmarks here, because also micro benchmarks, yes, it's a little bit smaller, but this allows us at least, well, not only to run this on SJ Octane, which already, or P3, which already takes long enough, but also run here this in a couple of hours instead of a couple of days. So everything compiles even longer. And also I think I've thrown here Ceiling 03 into the mix here with Ceiling Clang not as much slower. Take a look, let's take a look on the runtime, certainly most important for most people who are not interested in compiling this. So LTO, how much runtime do we get here? Coming from 02, yeah, 1 second, so here something like 2% or something. Here this is even slower. GNU PG from 02 this is so much to 03 is always faster, right? This is why I historically usually just compiled for a decade with O size optimization, because this usually performed quite well for me for throwing random code, OBS, Firefox, you name it. You really need some mathematical number crunching stuff for 03 to really become faster. Also, so compared to 02 to LTO, yes, that is a little bit faster, 19 to 16 and 03. So even so, you see here 03, 02, so somehow, where have I been looking at? Somehow this really is a little bit strange outliner here, but anyway, so this 03 here becomes slower comparing here 02 to 03, a second or two slower on GNU PG, and also here while 03 is slightly faster, somehow not with LTO. Here also the same, so it's not like one benchmark, it is also here lame slightly. So long story short, you cannot just throw everything to 03 and think it's faster. Sometimes it's not. Only here with set standard again, but then again, this is basically measuring noise here. Only the graphs only show here any movement, because we have here also other GCC 01 and such in here. Otherwise this is not moving here much in between 11 and 12.85 seconds. And a final look to Ceiling LTO 03 here, that is that line to that line, so that is also not moving as much, LTO 16, and yeah, so not really reliably that much faster. Maybe let's look and set standard. So yeah, I should have benchmarked 03. Stupid, obviously, amazing results. And also what I already wrote in a Linux magazine article a long time ago was when I benchmarked GCC 3 point whatever, that nothing beats writing optimized algorithms. So the compiler will only, usually with a C language anyway, transform the program in the algorithm you've written. If you have written a linear scaling algorithm or whatever, the compiler will not transform this mathematically in a much more clever, lazy, evaluated algorithm or whatsoever, or a completely different mathematic concept to the problem. So usually if you want to optimize something, already write very clever code. With that I'm not meaning assembly, I'm just meaning a clever algorithm that usually beats here this kind of stuff more than you see a decade of compiler research and development, and the results, yeah, they are sometimes a little bit faster, but sometimes also a bit slower, and you definitely need way more build time to achieve the result for just not that much of an improvement. Size-wise, we can take a look. I think I saw that this sometimes became even larger. Yeah, you see 03 size much larger than 02 or OS, obviously, and yeah, so size-wise much larger, and you have here reliable results. libmet with FLTO tier double the output size, but otherwise not necessarily double, but 25% larger binaries, you name it. And yeah, Clang, let's have a look there, or Clang 03 LTO. There it's not moving as much. Set standard even became slightly smaller. Maybe that was even the case for here LTO. Yeah, set standard somehow very good benchmark for this use case. Comments in the audience, Vodafone, hey, 0 frames, amazingly. And last but not least, did I even close this already? Oh, that was super clever. Let's see if we can find, oops, the history here. I had here a bug. Yeah, you have seen in the previous, this is what I wanted to show. In the previous video I said I could maybe fix that we could link time optimize with Clang, with the LLVM linker, but I took a moment of a look and then I found a bug report here, do not pass OS. This may or may not be the problem. Could be that this is similar code with a gold plugin, but whatever. But case in point in this case here, case in point in case. Anyway, there is a bug from 2017, so much to maybe this is still not after 2 years fixed upstream, so much to I can just quickly fix something. And the discussion here is the usual when I look in this kind of stuff, sometimes a little bit irritating for me. The people wanted to fix this here with just removing OS here, switching S and Z to 2. And apparently first I thought this is disgusting, you pass in the OS for size optimization and all you get is 02. But apparently they write here, so partially the people agree with me that they don't think this is expected behavior. Here like until everything using, wait a second, yada 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 something. Yeah, I agree. Someone agrees that it's a discrepancy. The driver should not drop OS silently and pass down 01, 2, or 3 without a warning as a minimum. And then it sounds like maybe the bitcode or the LLVM internal bitcode has already size speed optimization attributes, or has this already optimized. However, I would think the link time optimization should also have some property of optimize for size or speed, or how much to optimize for size or speed. Finds it a little bit strange that apparently This, according to this bug report, should not really have too much, if any, of a difference. In any case, you see 2-year-old bug report, and yet in 2019, unsuccessful one-man Linux distribution guy takes a look and the stuff still breaks, so YOLO, or I don't know. Maybe I try to import this bug. I could actually see if so this is in libdriver, so not sure if this is just a gold plugin. Yes, so you see gold LTO. This bug, however, does it look open, or what is here? Yeah, also each time needs review public, so maybe this is still not closed. I guess maybe not. But maybe this is not the same code as the LLVM linker, as this is apparently the gold plugin, maybe. So yeah, your mileage may vary, and this bug, some people were aware, but apparently nobody cared about. But for this 2T2, very preliminary, just the boulder plate there of an option and passing this down. This, as you see, it is not as easy with this binutils gold plugin and stuff, so it will not just work for every use case, but I added an option that could start to work sometimes a little bit. Maybe I will try to take a look, but most likely, because you have seen you need the binutils gold plugin, which I'm not the greatest fan of to start with, and maybe for the simplicity I'm dreaming here of keeping my system smaller, the whole code size footprint of packages that I need to maintain and update. So I will most likely, also glibc is super huge, right? Not the greatest fan of the GNU libc anyway. So I will most likely try to eat my own dog food here and try to switch to a Musel, so LLVM CLang Musel based, alternative Musel libc based system, just for the test and testing, making the stuff more stable. And maybe because then when I'm already on LLVM CLang, I feel like this infrastructure is slightly more, well, in terms of link time optimization, slightly more convenient with LLVM and the LLVM LLD linker there. So maybe I try to see if I can get most packages maybe to link time optimized with LLVM Musel based systems. But in any case, so much to, yeah, just use O3. Stupid, yeah, not so simple. Results are still, and people, if people tell me this it's just some micro benchmark, something, yeah, it is. It's some couple of different code bases, and you see the results are mixed, and I do not expect the results with other like Firefox Linux kernel to be that differently more amazing. And in any case, what lesson learned is most likely you cannot just slap O3 and all kinds of fancy optimizations on something and expect it to be magically the most fast. Anyway, I hope you enjoyed this update, learned something, and to see you soon for the next videos and such stuff to come.